Do you want to get an A+ in Cambridge igcse Physics? Make the smart choice of subscribing to Super Easy Physics and Mathematics. For sure you will benefit from Mr. Matthew wealth of experience of preparing students to get an A+ in physics.
Yes, this paper is 1 hour 15 minutes duration. So the basic instruction that you need, you are expected to answer all the questions. And secondly, throughout this paper, you are supposed to use a value of 10 for your acceleration due to gravity. The total mark for this paper is 80 mark. I wish you good luck. Yes, let's start question 1. A ball rolled down a ramp and onto a horizontal surface. This graph shows the speed time graph for the ball. The first question, state the time when the ball reached the start of the rough section of the surface. So the ball reached the rough section at this point there. So how long does it take? So the time taken, you can see there. .2 seconds. Explain how the figure shows that there is no horizontal force on the ball when it rolls along the smooth section of the ball, that is here, while it's rolling down the smooth section. So how do you know that there is no force? First of all, while it is rolling down that smooth section, you can see that the speed remains constant. So the speed is not varying with time, and once speed is not varying with time, that means the acceleration is 0. And once acceleration is 0, then the force acting on the object is 0, because force is a product of mass and acceleration. So the gradient of the ball is 0 while moving on the horizontal surface. Then the ball maintains a constant speed of 12.8 meters per second while moving along the horizontal surface, and it is not accelerating. Question C. Determine the acceleration of the ball as it rolls down the ramp. So let's go to the next section to assess the graph. So when we want to find the acceleration, so with this part, so we want to find the acceleration here. So we need to know, so we have to know the difference, the variation in the speed. So for you to find the acceleration, so you know the time taken to reach that maximum speed. So how long does it take to roll down the side? That is 1.5 seconds. And then what is the final speed? 12.8 meter per second. So let's look. We have the formula for acceleration is the difference in the speed, that is the final speed, final velocity minus initial velocity divided by the time taken. So we have that gave us 8.53 meter per second square. The ball starts from rest at the top of the ramp. Show that the length of the ramp is 9.6 meter. Now for you to do this, all you need to know that the distance travel in velocity time graph is equal to the area under the curve. So we need to find the area of this triangle to get that. So we'll look at this triangle. So what is the area of this triangle? So once you know the height, so you calculate the height, then you know the base. The base is the time. How long does it take? 1.5. The base is 1.5 second, and then the height is 12.8 meter per second. So we can find the distance, which is the length of the ramp is equal to area under the straight line. So what type of shape is the triangle, and then the area of a triangle is half base times height. So using the parameters that we have there, we have velocity, which is the height, then multiply by the base, which is the time. So half of it will give you the area of the triangle shown highlighted. So substituting, we have that, so that gives us 9.6 meters. So we have been able to show that. Question 2. Show a spring balance used to measure the weight of a baby. So we have this, the spring balance with the reading showing. Now the spring obeys Hooke's law up to the weight of 175 Newton. State Hooke's law. Hooke's law states that the extension of the spring is directly proportional to the load suspended on it. State the relationship between the mass of the baby and the force exerted on the spring due to the baby. So we know that weight is equal to the mass of the baby multiplied by acceleration due to gravity, g. So we have that the force is directly proportional to the mass. The reading on the spring balance is 8 kg. So the mass of the baby is 8 kg. Determine the force exerted on the spring due to the baby. So to do that, the force exerted on the spring is equal to the weight of the baby. So we have the mass of the baby multiplied by acceleration due to gravity, 10. So we have 8 times 10 will give me 18 Newton. The limit of proportionality for the spring is at a force of 175 Newton. Sketch the extension load graph for the spring. So if you look at that, within that limit is directly proportional. So within from here, for every value of weight or force below 135, that is a limit. But once the limit is extended, the extension of the spring is no longer proportional to the weight applied. So it extends faster than the weight. The baby is carried from the ground floor to the bedroom. The vertical height of the bedroom above the ground is 3.5 meters. Calculate the change in gravitational potential energy of the baby when it is carried from the ground floor to the bed. So GPE, gravitational potential energy, is equal to the mass multiplied by the strength of gravity multiplied by the height of the bed. So that will give me 8 kg multiplied by 10 multiplied by 3.5, and that give me the energy of a rise of 280 joule. So question 3, figure 3.1 and 3.2 show how a puddle of water changes on a warm windy day. So in this case, I think we're looking at the rate of evaporation. So if you look at this now on the roadside, then this was a puddle of water, and then 3 hours later you can see that the volume of the water have reduced. Describe the process by which the volume of water in the puddle decreases. So basically what you're going to look at now, you have to look at explain how evaporation take place led to the decrease. So in this case, the amount of water in the pool decreases as water evaporates. the more energetic molecule escape from the surface of the water, because for those particles that escape from the surface are the ones that are more energetic, so leaving the less energetic molecules of water in the puddle. Yeah, in this question we are going to be looking at basically state and explain one change in the weather that will cause the volume of water in the puddle to decrease more slowly. Basically, we are going to be looking at the factors that affect the rate of evaporation. So one of the critical factors is the temperature. So statement. So you have a lower temperature like on a cool day. So if we have a cool day that the temperature is cool, so what happens? Lower temperature or a cool day. So the lower the temperature, the lower the rate of evaporation. So then explain in terms of molecule how sweating help to cool your body on a hot day. Now what happens is that thermal energy in the skin is transferred to water molecule. So when that happens, the molecule that have enough energy to escape from the skin become water vapor. And with that, since the higher molecule with more energy have escaped, the one remaining on the surface of the body are the one with lower energy, so the temperature drops automatically, so leaving behind molecule with lower energy and therefore leading to reduction in your body temperature. Question 4. A sample of sand had a volume of 0.50 meter cube. The density of the sand is 1900 kilogram per meter cube. The specific capacity of sand is 1500 joule per kilogram per Kelvin per degree Celsius. Calculate the mass of the sample of sand. So for us to be able to do this, you remember that the mass is equal to density multiplied by volume. So we have 1900 multiplied by 0.050 meter cube, and that gives us 95 kg. So the mass of sand is 95 kg. Calculate the thermal capacity of the sample of sand. So you remember that the thermal capacity is equal to the mass multiplied by the specific heat capacity of sand. So we have mass 95 multiplied by 1500 joule per kilogram per degree Celsius. So that will now give me 142,500 joule per degree Celsius. The initial temperature of the sample of sand is 7 degrees Celsius. The sample of the sand is heated using an electric heater. The power of the heating element is 50 watts. Calculate the time taken to increase the temperature of the sand to 19 degrees Celsius. So you look at the temperature difference. First of all, you know energy is equal to thermal capacity multiplied by temperature rise, and we've already calculated the thermal capacity in the previous question, that is in II part of this question. So you bring that and multiply by temperature rise, the difference, that is 19 take away 7. So if you do that, we can now calculate. So we know that so substituting for the parameters that we have there, we give us 3,450,200 seconds. So you can convert that time to minutes divided by 60. That will give me 57,570 minutes. convert it to hour. How long will it take? So you divide that again by 60. That will give me 959.5 hours. In some country, the soil is too cold for plants to grow well. In this country, plants are grown in plastic pots and kept inside. The pots containing soil are placed on sand. The sand is heated using electric heater as shown. Describe in terms of molecule how the thermal energy is transferred from the heated sand through the base of the plastic pot. So basically, some sand molecule gain kinetic energy through conduction when heated. So that is how we are looking at the mode of heat transfer. So we are looking at the mode of heat transfer. So we are interested in energy transfer from the heater to the sand. Okay, so if we do that through conduction, then heat is transferred to molecule of the plastic in contact with the sand through collision. The heating element in figure 4.1 remains switched on. The temperature of the sand remains constant at a value above room temperature. Explain why the temperature of the sand remains constant. The reason is that sand is warmer than surrounding, and so thermal energy constantly is lost from the sand because the top is not covered, it's exposed. So the rate of heat lost to the surrounding is very, very high compared to the rate at which the heating is taking place. So the sand is not overheated. Now, a constant temperature rate of thermal energy supplied to the sand is equal to the rate of thermal energy lost from the sand. So the temperature of the soil remains constant. So a boy look at the image of a clock in a plane mirror. So the figure shows the position of the clock and the one of the eye of the boy. Now the question AI, draw a ray of light from the clock reflected to the boy's eye. So the ray leaves the clock, strike the mirror, reflected to the eye, but based on the principle of the reflection. So you have the incident ray and then the reflected ray enter into the boy's eye. Now, just a way of remembering, know the angle of incident I must be equal to the angle of reflection R, based on the law of reflection. This is the normal, which is an imaginary line perpendicular to the surface, to the plane of the mirror. The next one is mark and S, the position of the image of the clock. So what we need to do, the image is formed inside the mirror because it's a visual image. So you extend the reflected ray backward, and then how do you locate the image? The object distance is equal to the image distance. So you do that where the two rays intersect will give you the position of the image. So what type of image? Is it real or visual? It is visual. And why do you say it's a visual image? The reason is that the image cannot be projected on the screen, or is formed as a result of the intersection of imaginary ray, not the actual ray of light. The actual ray of light is the brown color, but these imaginary rays are the blue one that will show on this diagram. Figure 5.2 shows the image of the clock seen by the boy. So the time is reading 3 o'clock, but the boy now look directly at the clock. Draw what the boy see. So this is just a critical thinking. All you want to know, trying to assess your understanding of the property of the image formed by plane mirror. Image formed by plane mirror are laterally inverted, so they have a 180-degree flip, horizontal flip. So this 3 o'clock will flip to 9 o'clock. So you have that. So lateral inversion of image. So this is what the boy will see as the image of the 3 o'clock time. The clock is illuminated by a source of monochromatic green light. State the meaning of monochromatic. Monochromatic light is light of a single frequency or wavelength. Now, the green light has a wavelength of 5.6 times 10 raised power minus 7 meter. Calculate the frequency of this green light. So this is a question that is testing the relationship between frequency, wavelength, and the velocity of light. So mind you, in this question, there is a parameter that is not given to you, which is the speed of light. So you are expected to know that in the course of your study. And the light, the speed of light is 300 million meter per second. So you have that. So frequency is equal to the speed of light divided by the wavelength, lambda. So if you substitute, about 3 times 10 raised by 8 meter per second divided by 5.6 times 10 raised by minus 7 meter. So that gives us 5.36 times 10 raised by 14 hertz. That is the frequency of the green light. With that, we've come to the end of question 5. So let's go to question 6. Yeah, question 6. Show two bar magnets, the north pole and the south pole. Sketch the pattern and the direction of the magnetic field line between the bar magnet. So the field line points from north to south. So field line exits north and enter into the south pole. So you need to put the other one here, north, then the one below. And the property of field line, they never intersect. Okay, so this is the end product you are going to have. So this is what they expect you to sketch in between this point here. And you make sure that the line don't cross, because field line don't intersect. Now question B, show the same bar magnet with a coil of wire between them. So we have the coil of wire, a loop of wire. So, and then when it is being rotated, so now from mechanical, you are rotating a conductor in a magnetic field. So that is a generator. So what is the question here? Name the part label A, that is the slip rings. Okay, so these are the slip rings. That is what make the current to be an alternating current. Okay, the coil of wire is rotated in the direction shown. So this wire here is moving up and this one is going down. So draw an arrow to show the direction of the current and explain your answer. So you use your right hand rule. The feed go from north to south and then the current flow in this direction. So what happens? You have your force goes up. So the force goes up, the feed, and then the current. So that is it. So explain your answer. Then the feed direction, the motion of the wire, and the induced current are mutually perpendicular according to Fleming right hand rule. Explain how rotating the coil continuously causes the galvanometer wire to show alternating current. 1. The coil rotates and cuts the magnetic field between the magnet. this induces an EMF in the coil. The current in the coil is transferred to galvanometer through the slip ring and carbon brush. Then the direction of current flow changes with each 180-degree rotation of the coil. So actually this is just the principle that governs the operation of a generator. So with this we have come to the end of this question. The next one, question 7, is on electricity. It shows a circuit including a 12-volt battery and 2 identical lamps. So we have these 2 lamps. Now the 12-volt battery of the cell is connected in series. The 12 connected consists of cells connected in series. Each cells in the battery have an electromotive force. That's the energy that pushes the charges or electron around, determine how many cells are there. So the cells are added together because they are in series. So that will give me the number of cells equal to 12 volt divided by the electromotive force of each cell. So that gives you about 8 cells that add together. So 8 multiply 1.5 volts will give you 12 volts. Question B. When the switch is closed, the ammeter reading is 2.4 ampere. So we have these 2 parameters that we know. We have 12-volt battery. The current flowing is 2.4. Calculate the total resistance of the circuit. Total resistance is simply using Ohm's law. The PD across the system is equal to the product of the current and the resistance. So calculate the resistance. So resistance is equal to the PD, EMF of the battery divided by the current. So that gives me 5 ohm. So the total resistance, the 2 lamps in parallel with this resistor in series, will give you 5 ohms. Now, each lamp has a resistance of 3 ohm. Calculate the value of the resistance Q. So 3 ohm and 3 ohm connected in parallel. So this one will give me the product of the effective resistance is going to be half of it, which is 1.5. And since the total is 5 ohms, so remove 1.5 from 5. This will give me 3.5. But let's see how we show that using the formula. So we have the parallel added to this in series. So the parallel, so we have that will give me this plus this will give me 5. So for me to get Q is going to be 5 take away the effective resistance of the resistors in parallel. So that give me that, and so that's how we got 3.5 ohm as a resistance of resistor Q. So we expected to draw the voltmeter across that. So if the voltmeter across, we have it. It's normally the voltmeter is always connected in parallel to the resistor. Calculate the power supply to 1 lamp. The power supply to 1 lamp. What is the power? Power is equal to the current multiplied by the potential difference across the lamp. So we need to find the PD across the 2 lamps is the same, but we need to find the PD across this 2 lamps, and then the current flowing in one of the lamp. So to do that, since both of them are equal, they are going to split this current. The total current that comes will be divided into 2 equal parts. So the current automatically becomes 1.2 ampere. And then to know the PD, since we know that the resistance across resistor Q is 3.5 ohm, and we know the current flowing through, so we can find the PD across resistor Q. So the PD across resistor Q is going to be 3.5 ohm multiplied by 2.4 ampere, the current. So that give me about 8.4 volt. So subtract it from 12 volt. That will now give me the PD of 3.6 volt across the two lamps. Okay, so now let's find the power. So the current flowing in each resistor is half of the total current that flow into the parallel circuit. So that give me 1.2 ampere. So if you multiply, the power is going to be, the power flowing in each resistor is going to be the PD multiplied by the current. So 3.6 volt multiplied by 1.2 ampere will give me 4.32 watts or joule per second. So that is the power across it. So with that, we've come to the end of this question. Let's go to the next question 8. A radio is connected to the main supply using a step-down transformer. Step-down transformer is a transformer that reduces the voltage from the main. So draw a label diagram to show the structure of a basic step-down transformer. So a basic step-down transformer, you have the two coils. So you have the main coil, and then since it's step down, you have a fewer number of coils in the secondary part. So let's label. So that is a primary coil, and then this is the secondary coil. So, and then the iron core. So we have the iron core. So these are just the basic labeling of a step-down transformer. Why is it called a step-down? Because it's going to reduce the voltage. Higher voltage flow into the main primary coil, and then it induces lower voltage on the secondary coil. Explain the operation of a basic transformer. Okay, so for you to know that the basic operation of a basic transformer, the primary coil is connected to alternating voltage, and then the alternating voltage will cause a variation in the magnetic field, which will now induce magnetic field and voltage in the secondary coil. Okay, and the variation of the magnetic field affects the value of the. So we have that. So basically, you have the primary voltage cause an alternating current in the coil. So that means the primary coil is connected to a primary voltage. The primary voltage produces a varying magnetic field. Okay, the varying field induces EMF, electromotive force, in the secondary coil. So the full meaning of EMF is electromotive force. So these are the three-step fundamental principles that govern the operation of a step-down transformer. The voltage of the main is 230 volts. The output voltage of the transformer is 6 volts. So you see the voltage has been stepped down from 230 to 6 volts. Calculate the value of the turn ratio. That is number of secondary turn to the number of primary turn. Give your answer to two significant figures. Okay, if you look at that, so we use the formula for transformer. The secondary voltage divided by the primary voltage is equal to number of turn in the secondary coil divided by number of turns in the primary coil. So we have two of them. We have the secondary voltage is 6 volts divided by the primary voltage of 230 volts. So if you divide that, we give you the number of turns in the secondary coil to the number of turns in the primary coil. So that will give me 0.026. So that is the number of turn ratio. With that, we've come to the end of this question on magnetism. The next question is on logic gate. Okay. Figure 9.1 show a digital circuit. Explain what is meant by digital. A signal that has one of two possible states, so either high or low. Okay, high means switch on, low means switch off. So that is just the only two options you have in a digital gate. Okay, complete the truth table for the digital circuit shown in 9.1. So we need to identify what each of the the type of logic gates. So this is an AND gate. Okay, we have an AND gate, and then we have a NOT gate. So now let's look at the principle. Now if we look at the how does AND gate, what is the principle? For the AND gate, the output must be high. For the output to be high, both inputs must be high. So for the output to be high, that means for C to be 1 to be high, then both A and B must be high. And then for C to be low, both A and B must be low. So if you have that, so A and B will give you C. Now both of them are low, so what is going to happen? And so here is going to be low too. Then for both to be high, for the output to be high, both must be high. But if you look at this situation, A is low while B is high. But the principle says that both inputs must be high. So that's why the output here, C going to the NOT gate, is 0. Okay, the fourth situation or condition, so A is high and B is low. Now it's also going to be what? Low, because it's only one that is high. So both are high, A and B are high, so yeah, it's going to be high. So 1. Now NOT gate, what is the principle for the NOT logic gate? The output is high if the input is low. So what it does is it does the work of an inverter. So if C is low, what is going to happen to D is going to be high, not low. Then the second one here, C is low, then D will not be low, so 1. Then the next one, C is also low, then D will not be low. Then C is high, NOT gate, so D will not be high, so it will be low. State the single logic gate that will produce the same output D from the input A and B. So that is a NAND gate. So this is just the diagram for a NAND gate. And then if you look at the truth table for a NAND gate, so you have A and B, and then C. So if you look at it, let's review the NAND gate. So if you look at the rule, the output C is high if input A and B are not both high. So output C is high if output A and B are not high. That's how I got the name, not and. So A and B is not A and B result. Okay, so let's see. So if you have this situation, if A is low, C is high if both A and B are not high. So both, like this one now, both are low. So what is going to happen? If both are not high, so if you look at this, so it's going to be high. Then one of them is high, so it's going to be high. Then the other one of them is high. Then what about when both of them are high? Then and is going to give you not high. So logic 0 means low or off, while logic 1 means high or on. So question 10. The isotope americium 241 is represented by 24192 americium. This isotope decay by alpha emission to form neptunium Np. Now complete the nuclear equation for this decay. So we know once they say alpha is emitted, so what is alpha? Alpha is a helium nuclide, so which is what? 42. So we do that. We have 42 alpha. So what is the representation of the nuclei isotope neptunium? So for us to do that, all we need to do is how many proton and neutron? What is the nucleon number? So subtract 4 from 241. So that will give me 237. Then subtract 2 from 95. That will give me 93. So neptunium has that isotope representation. Okay. Now, figure 10.1 show a simple diagram of a smoke detector. The smoke detector contains a small sample of americium. This isotope ionizes the air between the metal plate in the detector. So we have this between these two metal plates. Okay, describe how the americium ionizes the air. So the first in alpha particle is emitted by americium, and as it moves, it travels through the air, and then the atom collides with the molecule of air between the plates. Then as they collide with the molecule of air, then the collision will knock off the outermost electron out of the molecule, and then so if you look at this, you say suggest and explain 2 reasons why smoke detector use an isotope that emit alpha particle rather than isotope that emit gamma radiation. Look at the basic property of each of these two radiations. Now, the alpha particle have a short range of penetration because of its size. It can easily be stopped, why gamma ray cannot easily be stopped. So, and then alpha particle is more highly ionizing than gamma, so what it means as well, alpha particle, because of its size, ionize air molecule more easily than gamma radiation, because the smoke detector is to alert the owner that there is a fire incident so that it can easily be detected on time. So if you use gamma ray, it's going to take a longer time before the alarm will come off. Alright, the other one again is that for safety of the user of the smoke detector, alpha particle has low penetration, so the molecules are easily stopped, so and it cannot travel or harm the human being using it, which is unlike the gamma radiation, which have deep penetration and cannot easily be stopped by the human skin. So with that, we've come to the end of this question. So this is the end of IGCSE paper 4 variant 2 February-March 2022, and I hope you have learned something new while we were reviewing this paper. The essence of reviewing this paper is for you to have an understanding of how the questions are framed, the command words, and then for you to know how to answer the questions. And as you keep on reviewing questions, I know with time you can easily build up your grade in physics. I wish you good luck as you prepare. Thank you for learning. So this is the end of the review of this paper. So watch out for another one that will come. Share it with your friends and subscribe to this channel.